The IM9202 Hioki test fixture can measure both SMD devices and leaded devices with just one unit. It can also measure irregular shaped components like RFID and NFC tags. Recently, switching frequencies in power circuits are rising above 1 MHz. This brings about the need to measure the characteristics of devices used in power circuits and high frequencies. The IM9202 can also establish contact with devices with complex designs such as RFID and NFC tags. Use the Analyzer mode in the Hioki IM7580 impedance analyzer to help you easily identify the characteristics of these types of components. Here you can see the resonance characteristics is 13.56 MHz. As you can see, the Hioki test fixture IM9202 provides an easy way to measure components at high frequencies.
Yeah, good morning, everyone. So I'm Deepak from Hioki India. So I hope you all guys are able to see the screen, right? So now it's time to start the session. So I'll introduce myself again. I'm Deepak from Hioki India. I'm looking after the pan-India sales market. Right. Today, as per the topic, we are going to start the session by this time now. And I'll introduce you about this platform, right? How to use and what all things are there. So today with us, we have three speakers. The expert speakers are with us. So as per Indian Standard Time, we are going to start by 11:30, and by Middle East time, it is 10 now. So the speakers with are Mr. Richo and Sarath and Midun. So they will be speaking related to this topic for a certain period of time, and then we'll move towards the Q&A session. So points to note in this session, on your left side, you will be seeing the platform where the you can upload those things, and on your right side, you will be able to see the screen and the presentation given by the speakers. Right. So this is how the platform looks like. This is called the GoToWebinar, which we are using today. And the first things is the key is here to minimize this platform, and then you will be able to see the full screen of the presentation. Please note that you need to select the computer audio here, right? Like this, you need to select it like this, and below there's an option to check rest of the things, right? Now, if in the presentation, if in this session, if in any time the connection get disconnected, maybe because of the internet or because of the software, then please use the same link to join back the session again. And then related to the certificate, yes, we are providing the certificates here. These are the e-certificates, but there is a clause you need to attend at least 90 minutes to get this certificate, right? So please attend this session for at least 90 minutes to get this kind of certificate. And this session is automatically recorded, and we can share you the recording as well, the link of the recording. But it takes almost 48 hours to render the video, and then we can share you after 2 days. So program for today is, this is the schedule. So as per the Indian Standard Time, we have started by 11:30, and then I will the managing director of Hioki Middle East team. He will give the opening speech, and then the session will go for almost 1 hour by the speakers, and then we'll jump to the Q&A session. Maybe it will last for 40 to 45 minutes, and then we'll close the session by the managing director of Hioki India. Right. So let's try to be more interactive in this session. You guys able to see the Q&A box on the platform, and if you guys have any questions, please drop down your questions over there. You can write the questions, it will come to me, and then after the presentation session, we will discuss about your queries. Right. So this will be the Q&A box where you can write, and then it will come to us. So further on, related to Hioki products, or if you want to have any kind of suggestions, or you have further questions, then please drop email to me or to Mr. Anil. So Anil is sitting at the UAE. He's looking after the UAE market. And related to India, Indian customers can drop me email. My email ID is deepak@hioki.co.in, and Anil is anil@hiokimea.ae. So as I introduce, these are the speakers with us. So they have a wide experience about this particular topic. And I hope this session will be very useful and beneficial and knowledgeable for you all guys, right? Now I will ask Mr. Iji Sakai, the Managing Director of Middle East Hioki. Please share your thoughts and words with us. So over to you, Iska-san.
Good morning, everyone. My name is A. Sakai, Managing Director of Hioki Middle East Office. Thank you for joining this session. I hope all of you are safe in this COVID situation and welcome you all to this webinar on energy audit organized by Hioki Middle East and India Office. I take this opportunity to also welcome two speakers for today's session, Mr. Dijo, Mr. Sharat, and Mr. Midom. Thank you for your efforts. Once again, thank you everyone for we shall proceed to the session.
Thank you, Sagai-san, for kind words. Now I will request our speakers to introduce themselves because they can introduce much better as compared to me. So I will ask them to introduce themselves and then we can move ahead towards the presentation. So now over to the speakers now.
Hello, hi, Deepak, can you hear me? I hope I'm audible. Hello?
Yeah, it's clear, it's clear.
Great, great. All right, first of all, I would like to thank Hioki for this opportunity. And I mean, we're all going through difficult times. So in this difficult time to actually organize and impart knowledge to the general public, really kudos and applause to the whole team for Hioki and also giving us this opportunity to present our knowledge, what we've learned in the field for the last few years. So it's definitely, I would like to give all the praise to Hioki. Just a bit about us. So basically, today we'll be talking about an introduction. We'll be giving an introduction to what energy auditing is about. So getting into what would be the requirements that need to be done to carry out an energy audit, as well as focusing on some specific layers of what is air leakage testing and how does electrical inspections also play a part when coming to energy auditing. So myself, my name is Rijo Abraham. I'm basically looking after the energy management as well as the electrical inspection side of things at the company. So just with me is also Sharat and Mithun. You will be meeting them later on when they do the session for their respective topics. But just to give you a glimpse into our portfolio of services that we offer actually to support our clients. I believe the screen is appearing, right?
Yeah, video we can see. Yeah.
Great. So as mentioned, today we'll be discussing about energy audits. We'll be giving an introduction, and the focus will be mainly on mixed-use buildings. So we also look at factories, industries, but today's focus would be looking at mixed-use buildings. So we basically, a company is based out of UAE. So most of the buildings, commercial as well as residential buildings, play a huge part, in the overall energy mix of the place here. So I'm just going to move into what our agenda would be. The whole presentation is divided into three phases. So the first one will look at giving an overview of what an energy audit is with respect to mixed-use buildings. Then we would we would give a focus on air leakage testing specifically for buildings, as well as how an electrical testing inspection is also a very important part of an energy audit. So just a quick glimpse on our services before we proceed to the presentation. So Constant looks at providing green building consulting as well as electrical testing services. So on the green building consulting, we do provide services like air leakage testing, which is where we quantify the leaks through different buildings. So this is basically used or utilized during different green building certification requirements. Also water leakage testing, infrared thermography, tobacco testing, commissioning, confirming or validating indoor air quality, duct cleaning, energy modeling. That's something that we deal with on the green building consulting side. Then if you focus more on the electrical, we have electrical safety testing, which Mithun would be getting into later on in the session. Power quality audits thing and lighting testing. So basically anything with respect to electrical testing is also something that we carry out. With respect to certifications, our team is a mix of mechanical electrical engineers, and we have certifications like the CEM, CA, CMVP, LEED. These are certifications that look at more on the energy management side. And then on the also for green buildings, we have engineers who are certified in LEED as well as STDAMA, which is STDAMA is a sustainability certification for Abu Dhabi stock of buildings. Apart from that, our team is also certified as level 2 thermographers as well as air tightness testing experts. So again, my colleague Sharath will be talking more on details on that in the coming slides. So to begin with, so the main topic will be looking at energy audits, but I would like to keep a focus on buildings as such, because buildings, if you know, is a very huge source of enormous energy efficiency potential. So we have a huge potential to bring in savings as well as cost savings if we can actually focus on buildings as a whole. Now, if I move on to a survey taken by the UNEP Global Report, it was revealed that around 35 to 40% of buildings actually are allocated for the overall global energy use. So if you look at different industries like transportation, factories, you have 40% of the energy consumption actually coming from the building use. So now this, if you look, also includes, there's a portion in the slide which shows construction industry 6%. That actually is, or the construction industry which produces raw materials or materials of constructing buildings are also included. So it comes to around 36 to 40% of the consumption is basically from buildings. Similarly, if you can look on the right side of the chart, you can see that around, again, 35 to 40% of CO2 emissions is actually coming purely from buildings. So which means that we have a good area to focus on just by, focusing on mixed-use buildings, which is residential and commercial buildings. We have a good chance to actually reduce the overall global energy consumption. So that's why today's focus for us would be to look at energy auditing within in a mixed-use building space. Now, my question would be, what is an energy audit? So if we keep it simple, it's basically an inspection, a survey, or an analysis of an energy flow across the facility. So if we can identify how energy comes into the building and leaves the building, and this we can do through different inspections, survey, and analysis, and we can identify what are the opportunities we have, which are kind of, maybe some of them are visible, but many of them are hidden as well. So we are able to identify what are the different opportunities that we can get within a building. Now, the idea is that it does not affect the final outcome of the building itself. So it should not be that we find an opportunity that brings the overall quality of the building, but we improve it and we're able to save energy and utility bills at the same time. So ideally, what we're doing is an energy audit is done to determine a where, a when, a why, and a how of how it flows through the building and the facility. So, and if you look at the main key outcomes that's expected from an energy audit, we're looking at identifying some major consumers and wastages. So with respect to, let's say, a building, what are the components, what are the assets, what are the systems that actually consume most of the energy? So consumption is one part. The other part we sometimes don't focus on is the wastage. So equipment might be functioning, but it might be wasting a lot of different energies, or different, it might be actually running on a different frequency. It might be running on different patterns, which might not be required in the building. So these are actually opportunities which we can find out, which in most cases sometimes remain hidden. Once we have this, we can recommend different energy efficiency measures and then identify what is the saving potential associated with each measure. And finally, it's all about feasibility. So there might be 50 to 60 solutions that maybe we can cover over buildings after an audit is done. But what exactly is feasible for the end user, for the client, in terms of financial as well as the quality improvement to the building should be considered, and that's something that is something that we need to look at the core. So if we can look at an energy audit, there are two ways of actually looking at the outcomes, as well as how do we plan for it, right? So there are two ways of looking at it. One is on the strategic side. So on the strategic side, we do an energy audit. Would be number one. In many countries, there might be legal requirements that we have to comply with some legal requirements for energy auditing, for reduction in consumption. Maybe on year consumption should be reduced by a certain amount, or an audit is mandatory, or so there are some legal requirements. So each company or facility owner should actually take this into consideration, and this is one of the whys of doing an energy audit, again on the strategic level. Another thing is even for on the financial side, it helps you to really plan for how your building is operated, really understand where you need to allocate money to improve the overall life cycle. At the end of the day, the facility is built for the user. So whatever helps to improve the quality of the building would actually add a bonus, or it would actually help in the overall life cycle of the building, and finally it benefits all the end users. So looking at on the strategic side for financial prioritization, this energy audit is required because it helps you to identify where to actually put your money into what system improvements and so forth. The other thing that it helps with, or we need to take into consideration on a strategic point, is it obviously helps on a corporate social responsibility goal. So many companies and facilities, building owners look into this point of how it can actually comply with CSR requirements, and it also actually helps because it's no longer just a reduction of costs. It also benefits how the user actually enjoys the working of the building. So when you do an energy audit, you end up not only just saving costs, but you improve the air quality of the building, you improve the usability of the building. So all of that actually helps to benefit the users as well as the people actually interacting with the building. So it also complies with corporate social responsibility goals of the end user. Mainly, again, looking at customer and shareholder expectations. So we work around, to really work with the end user, the customer, the shareholders' expectation. And this, again, is a strategic requirement or a why to do an energy audit. And finally, on a strategic point, if you look at the major companies now, like Amazon, they're actually focusing on reducing their carbon footprint. So now, all of the whole world, the globe is actually going through a difficult situation at the moment. And this, I believe, is a good point of time for us to really focus on how we can reduce our carbon footprint, optimize our resources, in the current time and moving forward into the future. Now, on the tactical level, which means more on the field level, if you look what an energy audit does or why is it required, if you look at what it looks at is the energy performance of the building improves. Energy performance of the building is operating energy efficiently, which means it also improves the usability as well as the cost of running the building comes down by a good percentage. Next is it actually reveals how energy is being wasted. So as I spoke earlier, energy wastage is something that we really need to consider while carrying out an energy audit. So how is the building actually working? How is the operation of the building, and where exactly is the energy being wasted, so that we can actually focus to reduce that wastage. Then another thing that happens with an energy audit is that even if a building owner or a facility owner is running the building and operating it, there are areas where some things are hidden. An energy audit actually reveals those things and helps in understanding the operation of the building itself. So things like how was the energy usage for a particular time period? Why did it increase? Why did it come down? Why is it that during a time where it was winter, cooling utility bills were higher? So there are things that maybe it might remain hidden, but through an energy audit, we can identify these things. Another thing is we understand how that particular building itself operates. Is it a school? So is a school supposed to operate in a certain profile? Is it an office, commercial office building? It's supposed to operate in this profile. Why is it not operating in that required profile? So all these we can look at. Another thing is focusing on the tactical side is the technical opportunities. So I believe we all are a generation where we are improving. The processes are going from better to better. So one of the things energy audit reveals is basically how the system itself is operating, how an asset is operating, how a building is operating, and how it can be improved over a period of time. Now I'm going to get into the different levels of an energy audit. This is as per ASHRAE. So ASHRAE is the American Society of Heating and Refrigerating Air Conditioning Engineers. I'm sure most of you might already know about this, but if you look at an energy audit, it has been divided into primarily 3 levels. But even before the 3 levels, there is something called a primary energy assessment, which is basically looking at your utility bills. From whatever data is available from your utility bills, an assessment is done to understand what are the energy consumption profiles of a building, how exactly is it working, are there any anomalies in the consumption. All this is assessed in that primary level energy audit. So if you look at it's a very much a required part of the overall energy audit process, and this is something that we really look into. Then ASHRAE level 1 combines the primary or the preliminary energy assessment along with a site walkthrough. So ASHRAE level 1 is done when the building owner or the facility owner wants to understand how the building is operating, as well as how what is the potential for energy savings within the building. So maybe he's not planning to actually carry out a retrofit or an implementation of a measure really soon, but he wants to get an idea of where exactly the building is at the moment with respect to other buildings. What is the potential in my building? What are the measures that I can potentially implement in the near future? And once I have that, how long will I take to recover my money? So all this gives you like a very high level view on where your building's performance is. Now let's say the building owner has already done an assessment, and basically the walkthrough audit has been done, or even if it hasn't been done, the building owner has an idea from the operations team where the building lies, and the building owner really wants to bring in savings. Then an ASHRAE level 2 is recommended, which basically includes the preliminary assessment and the level 1 walkthrough, but along with that, detailed measurements are done. Detailed measurements of your assets are done. So if you look at your HVAC systems, if you have chillers in the building, then the chillers performance is assessed. The performance is looking with respect to the occupancy, the load in the building is assessed and seen how the equipment is functioning. It looks like the electrical systems, the power quality within the building is assessed. It looks at how your different pumps are functioning. If you look at the ventilation side, how are your fans functioning? What are the motors? What level is the requirement in the building versus what is the asset actually providing? So all this is assessed. So that is the ASHRAE level 2. This gives you a pretty good understanding of where your building is at, as well as it also tells you that into more a deeper level of accuracy, that the X amount of savings can be achieved if you put X amount of money, and this is how much of time it will take. Now, when you have, let's say, you want to really move into retrofitting, and your goal is to retrofit a building, then what is usually recommended is an ASHRAE level 3 audit, which basically looks at whatever has been done so far up to the level 2. But again, readings are taken for a longer period of time. You have more. The idea is that you're moving from, as we move through the different levels, we're moving from more the accuracy of the savings as well as the overall proposal for the building increases. So ASHRAE level 3 would include things like maybe HAP. So you have your hourly analysis of your, the readings with respect to temperature. You look at building a calibrated model of the building to actually give you a more clear idea of how the building works. So it's going to be giving you a more clear and accurate model of your proposed savings. So this level of auditing would also include, in some cases, also calibrated or a simulation model on the done on the system. So there are different softwares out there called like IES, eQuest, where we also model the building and also have a higher level or a longer level of measurements of the assets taken, so that we have a more clear picture of the energy savings. So if you look at the requirements in terms of the levels, each level, if you look, it builds up on the previous level. So it's not that it's isolated from each other. Again, how do we choose or define a level of an energy audit? It depends on what the end user requirement is. So I'll be discussing that, the importance of actually sitting with the client or the end user to understand what is the final outcome expected, because the level is defined based on the client and the requirement of the building. So for example, if it's a building where there is not much potential to save, then maybe the cost of carrying out a national level 3 audit won't justify that. But maybe they just need to understand where they're at, and they can actually bring sufficient savings by doing a national level 1 audit. So it depends from case to case. So one thing to understand is that each level builds up on the previous level. It's not an isolated inspection. It's on what the client requirement is and what the facility requirement is. So from what we understand, the audit complexity increases. So as the level builds up, there are more tests done, there are more measurements done, there's more time on the field to get more data. So the more data we have, the more structured solution we're able to provide to the end user and client, and it justifies the cost as well. And then finally, if the building has potential, definitely this effort, the more effort we put in, it does translate to a higher amount of energy savings. So that's how this levels of energy audits work. So what I would like to leave with you for this specific level of energy audit is that it does not work isolated from each other. It actually builds up from the other levels. So it depends highly on what your requirement is or what the client requirement is. So if you look at this slide, it basically shows you what are the different things that we will be looking at. And this is again as per ASHRAE guidelines. So a preliminary energy use analysis would be the first level. So usually it's also called level 0 at times. So this level basically looks at understanding what is your annual energy consumption, and you would look at having a performance metric like kilowatt hour per meter square. So kilowatt hour would be, let's say, if you're looking at an electricity consumption, what is your electricity consumption across the 12 months of a year, and you divide it by the overall area of the building or the facility, and then this is compared to a benchmark, a standard, and we are able to relate where does the building stand. So this gives you a very, very high level view of the building before we start on, where we move on to the other levels. Level 1 is a walkthrough. Again, it has the preliminary energy use analysis along with a walkthrough or a site or a walkthrough with an experienced energy auditor, can reveal what are the typical things as well as the hidden things that can be identified within a building with respect to performance of an asset or even wastage. So it would also have a rough cost estimation and saving estimation for each measure that is proposed. And we are at the end, it will be looking at identifying what capital projects can be implemented across that facility. Now, level 2, again, it builds up from what we finished with preliminary energy use analysis as well as level 1. So level 2 also includes an energy end use breakdown, which is basically looking at what are the different assets and systems within that particular facility or building, and which asset is actually consuming more of the energy. I'll be getting into the details of that in the coming slides. Level 2 also looks at the detail analysis. So there's more details because we have higher amount of data that we've gathered from the site, and we're looking at developing a proposal that is giving you more information and a reduced risk with respect to each solution that is proposed. And it includes a more detailed level of cost and saving analysis, as well as operation and maintenance charges with respect to maintaining that new improvement to that asset or a completely new asset itself. O&M charges as well as are included as well. Now level 3 takes it to a notch up higher. So again, it's building up from what level 2 has done. So it has a more refined analysis and it has additional measurements. So maybe if you're looking at, if maybe level 2 audit maybe had the chiller logged for a period of, let's say, 1 week or 10 days, we would take maybe more measurements. Maybe we might take across different seasons. I mean, again, it depends on the building type, but the idea is that there's more data taken for each system, and things like hourly simulation are done to see how that building's requirement is in terms of cooling or heating load based on the season, based on the area they located. So all of this is taken into consideration as well in level 3. So this level 3 is basically your the highest level of accuracy that you can get from an energy audit. Now, if you look at some activities with respect to the different levels, as you can see that level 1 would have, like I mentioned before, a preliminary energy analysis. There's a walkthrough survey. It would have identification of low cost and no cost measures. We also have a solution of the different capital improvements that can be done. Now, level 2 on top of that adds also review of the M&E, mechanical, electrical, plumbing, design, and O&M manuals. It looks at the different drawings. It goes again, more data, more time is spent on the field, so it would focus also on reviewing the existing drawings and system information sheets. Level 2 also looks at the difference between level 1 and level 2 would be mainly on the measurements done. So we'll be using instruments to get data from different assets. Again, I'll be discussing that in the coming slides. Again, focusing on analyzing capital measures. So there'll be more detail given to level 2 audits versus level 1. And you also would again meet with the owner and operator to review the recommendation. So level 2 would be again, so that level 2 takes it to, the idea is to bring it to implementation of the solution. So there will be detailed sessions with the owner to see how feasible it is, engineering technical wise as well as financial wise as well. Now, if you look at level 3, you have everything that is already done till level 2, but you're also adding requirements of additional monitoring, whether it be as maybe a system that like a pressure handling unit, which would require also to basically monitor the air quality. So maybe we might need additional air quality readings, or maybe we might need additional airflow readings. So it depends on how we would be integrating that as well. So maybe having additional sensors, maybe a remote monitoring system installed for a period of time. So that also would be included. And even maybe high level engineering revision done to a system, it even goes to that level of audit. Then again, looking at in terms of what are the outcomes expected in a report, you would look at the on level 1, you look at the savings as per the utility rate of that area that you're located in. You would look at UIs, which are energy use index, your utilization index. Basically, it's the energy consumed per meter square in 1 year. So you have that metric, as we discussed earlier. You have those metrics as well included in level 1, and you have different estimations of savings if you were to meet that EUI target. So it's basically a high-level report. It's a good start for a building that's never done any energy management before. Level 2, again, like I said, it builds up from level 1 and level 3. So you can see the different activities that are done with that. Now, the energy audit process, if you look, has 2 distinct phases. Phase 1 would be preparing for the audit, and that is done in line with the preliminary analysis, which I'll show in the coming slides. Phase 2 would be of an energy audit would be a site visit and then the reporting of that. So if you look at phase 1, which is preparing and pre-analysis, the very important step, like I mentioned before, is meeting with the client and agreeing on the approach or the validation of the scope itself is required. Because what we've noticed, or what I've experienced in the past, is that you might be going in one direction, the client has another expectation, and you never meet, and then it always ends up in bearing no fruit. So the idea is to sit with the client and the end user and have a workshop to identify, because everybody wants to do an energy audit, but what is their final expectation or outcome? That is very key to understand. So to sit with the client to understand what are the requirements, what is the core, is it financial savings, is it a CSR requirement, is it a legal compliant requirement, or is it a long-term plan they want to retrofit? So with that, all that data needs to be that needs to be discussed with the end user to understand why they're going for this in the first place. And then once that is done, we need to confirm the scope. And once this scope has been validated and confirmed, then we need to collect preliminary data like utility bills. So I'll come to the next slide where I show you what data we would require to take. The other key important part of an energy audit is identifying key personnel from the client side or the client representative that we can coordinate with during the energy audit, because it's not that the energy auditor comes into the building and then is left alone and not able to get sufficient data. Because the more data we have and the better understanding of the building's facilities, then better solutions can be developed via the energy audit. So identifying those key personnels, who are the people who is managing the plant, the operation and the maintenance of the building, who are there any energy efficiency measures implemented currently. So that is required. And once we have identified that and we're able to get the data, we would look at developing an energy use baseline. What that means is what is the standard energy consumption of that particular facility on a 12-month period. So this is a reference point for us to understand that this is how the building is operating. This is how much of electricity or water or chill water consumption is available in that building, and this is a reference point for us to make any future savings from. And before we move on to the site audit, the on-site, on-field measurements, we would need to make a checklist, because I mean, we would have a general amount of checklist, but every site is unique. Even if it's the same type of building, every site is unique. So what area do we focus on? What checklist do we need to be made to make for the site audits need to be taken into consideration? So like I said, introductory meeting with the client is very important. So why do we need it? I'll just repeat, show this again. Basically, it's setting the context for the energy audit. What is the scope? Why do we need to do this? What is the purpose behind the energy audit? That it lays the context, or a framework of why this is required in the first place. It validates or confirms the scope of energy audit. So we need to, again, sitting with the team and having a discussion to really understand what what is needed, and it is finally confirmed in writing. This is the objective of the energy audit. And next thing that we need to do is engage with the organization personnel. So again, identifying those key personnel and identifying what exactly is the assets that is taken care of by which team, and how we can actually work with those teams to get that data. Finally, from those meetings, we have to agree on an approach on this. We would have a plan, we would give it to the top management as well as the field team to agree on an approach that we would be taking to reach the objectives. So data collection side, when we would request this from the team. So you have at least 4 levels. I mean, I'm not saying that this is just these 4 that we would take, but just for the sake of the presentation, I've put in some core data that we would usually request from the client. So utility data will include electricity, water, chill water. You have your TSC, which is your treated sewage effluents. All this data, the consumption data is requested from the client. And if they have access to any online billing, that is also welcome. So if they have BMS data on the system that actually measures consumption or readings, that's also taken into consideration. The data to be acquired would be on the building side, like drawings of the building facade, the overall layout, site plans, then the asset list of MEP equipment across the building, the lighting layout, the lighting asset list. Then you have different process flow diagrams. In certain buildings, if it's district cooling, you have different sets of pumps. So you have a primary, secondary, and even tertiary pumps for a very high-rise building. So we would take that into consideration. We would look at what are the specific energy users. So some buildings usually keep a track of what specific energy users are. So maybe get that data as well. In terms of operation, try to understand, it is to getting the data to understand how the building is operated. What was the building initially made for to be used as, and what is it working as now? So historical data or whatever is available, like occupancy, then weather data, which we usually take it. We have a resource to take that from, but if it's available with an on-ground team, if they have an on-ground weather station, we can take it from there. Details of any upcoming changes in the building that's expected, because any change of the usage of the building can impact consumption. So all that will be taken into consideration. And finally, any energy management initiative that's already been done or implemented or in process of being implemented, all this data is welcome to actually get this audit plan developed. Again, identifying key client facility personnel is very, very important. So I think I had explained a bit about this in the previous slides, so I'm not going to spend more time on it, but it's very key. It's a very important process of the energy audit to have, because most times we have discovered that the facility management team or the operation and maintenance team on site feel threatened when an energy auditor comes. So it looks like we are trying to point their mistakes, but actually it's to work as a team. So to meet the key people who are actually driving the maintenance and the operation, is to meet with them, actually to gel with them, to tell them this is not fault finding exercise. This is actually to help build the overall team as well, and to look at opportunities where a third person might need to come in and look at it. And always we try to get buy-in from the field team, as well as a buy-in is required from the top management. So whatever the top management decides, it actually cascades down to the whole team. So that's something that we look at. So we try to build a rapport with the on-site team before we enter into an audit. Now, a preliminary analysis, which is again a level 0 or an analysis done before the audit itself, would look at understanding the nature and the quantity of energy consumption. So what are the different types of utilities and energy consumers in the building that would be needed to be understood. The next thing would be looking at understanding how the building operates. So operating the regime of the operations. Is it working in the night, in the morning, in the afternoon? Is there a peak consumption at a particular time? So all that will be looked at. Next would be looking at what are the major energy consuming equipment. So do you have an HVAC system? Do you have boilers in the building? Do you have maybe pumps that are not that are running full time throughout the working hours? All those need to be looked into. Identifying the requirements for any temporary metering or spot. So we would need to see specifically what meters are available in the building, and if not, what do we need to add. So that would be also taken into this whole planning exercise. And then once we have all this data and also results from the preliminary analysis, we would basically build a checklist. So this basically prepares us before we go on the site. So rather than going on the site and just not having an area of focus and just getting lost, because in a building there are different things to look at, we would basically from this data and this analysis, we would be able to really focus on those systems that will add maximum value to bringing in solutions. Not that we will not cover the entire building, but it gives us direction for us to move in. So the preliminary analysis data is taken in along with the other data we get from the site team to build a checklist, which would actually help us to work our way forward. So preliminary analysis, it looks at getting the utility data, and once the data is received, the auditor would have an initial review of the bills. So I'll just show you a few trends and graphs which might give you a better understanding of what I'm talking about. But it's basically analyzing the different bills to understand what is the baseline consumption or reference consumption of that building, where is it at, and are there any anomalies or any major spikes in consumption noticed. And so this will allow us to really be ready for the site visit or on-field assessment. There's also another statistical tool that we use called regression analysis. So I'll talk about that as well in the coming slides. So preliminary analysis is getting data and creating trends, which would give us a visual on where exactly there looks like some issues. So maybe if you can see the first trend, it looks like these are the same day across the different months. But you see, if you compare Jan, the first reading with the reading on maybe in the center of the trend line, you can see that there's a spike in the consumption. So the idea would be to again sit with the client end user team to understand why there was a spike. Was it an event that happened, or was there any requirement for the spike? So this is assessed. So these sort of things can be brought forward. Then you can see the next picture would be looking at that trend that is noticed. So you can actually look at the trend of consumption across the years or the months to identify what the consumption is. Also, what is the consumption when you look daily, weekday versus weekend. So as you can see on this particular area on a Friday consumption, you can see that the trend has actually of consumption has dropped for a specific reason. So this needs to be understood along with the client team to see where we can improve. Also, if they have daily power readings based on different variation of a week, we can actually further study to see how the trend of consumption is. We will also look at different panels. So if you have maybe different MDBs feeding different loads, we can see which MDB is actually consuming more energy and focus on the assets that are connected to those MDBs to optimize the consumption. Also looking at things like, if you have a cooling load, how has it been compared to what is the base load, or at any point of time across the 24-hour timeline, what is the requirement of cooling for that particular building, and what is a weekday versus a weekend consumption. So all this is analyzed actually. And then as I spoke earlier about regression analysis tool, it's basically to understand what is a major driver or a variable that would be needed to that is actually driving consumption across the building. So I mean, here in UAE, most of it is attributed to the weather. So we actually correlate weather data and the energy consumption or the electrical consumption or the chill water consumption. Basically, we are able to do a statistical model and predict to see how the model fits the drive of the variables. For example, you will see that weather and occupancy are a major driver here for a mixed-use building. So maybe a combination of that actually gives you an understanding of where the building energy consumption is driven by. So I mean, again, in a factory, it would be looking at production and things like that. But in a building, especially in this part of the locality, we would encounter the weather-driven energy consumption. Now, one more portion of the preliminary analysis would be to do a benchmarking. So we have standards like SIPC, ASHRAE, and also some green building standards, which tell us what is a typical consumption standard of performance. So like I mentioned earlier, kilowatt per hour per area per year is a performance benchmark used, and this would be compared with other standards in the standards to see where the building is at the moment of time. So as you can see, this is just giving an example of how an benchmarking exercise where energy utilization, which is again kilowatt per hour per meter square per year, you can see that compared to 15 and 16, 2 different years, the EUI factor has actually reduced, which means the performance of the building and energy consumption has actually improved. Again, looking at creating a baseline, just showing some charts of how the baseline would be. So once we have the data of the utilities, this baseline is frozen, and this would be our reference standard moving forward. The phase 2 would look at now, once the preliminary analysis, our planning has been done, we have an idea of where to focus on. So the building would look at basically getting the measurements taken by the energy auditors, and site visit along with reporting is this phase 2, where the initial step would be to have the site audit measurements taken. Then after that, we would understand how the building is operating. We would analyze the different energy practices already employed across the building, or if not, what are the practices they have planned, or what are the practices that can be implemented on site. So we understand the usage on site. So this would be more tangible because we're on the field. We're actually seeing the reality of the systems, how they operated, how long they're operated for. All this data is taken into consideration, and everything has to be finally brought down to bring down to create a feasible solution. So it has to be more visual. That's why we would include a lot of graphical interpretation of what like you've seen, trend lines, plots, graphs, charts. All this would be taken into consideration and to bring out the solution. Finally, at the end of the audit, we are expecting a easily understandable report, because different levels of people would be reading it. So we would have an easily understandable report that shows you the energy saving potential of the building and how long it would take for the building to recover the cost as per the implementation. So what are we going to focus on in a building service audit? For a typical mixed-use building, we're looking at focusing on the building facade. So Sharath will be speaking more about air leakage testing in the coming phase, but mainly looking at the building facade. Is it airtight? Is there air leakage in the facility? Why is it important to actually have your facade checked? So that is one area of it. Then in UAE, and at least in this local region in GCC, we have a temperature-driven energy consumption. So HVAC consumption usually accounts for around 50 to 70% of overall building consumption. So that is something that we would look at on the HVAC side. So in this case, it could be you might have water cooled chillers or air cooled chillers. Maybe you have DX units. You'll have your fresh air handling units connected to your chill water systems. Then you have your pumping system. It could be for pumping your chill water. It could be for your domestic water, potable water. It could be for landscaping. So we need to analyze all of that. Lighting is also a good amount of consumption also considered. So if you can look at this is basically one of the things that we would do as part of our audit is to actually create an end-use breakdown chart. So this is to understand which asset or system is actually consuming most of the energy in a building. So if you look at this particular building, again, it's just a sample. It's not giving you actual values, but in most cases, what we notice is that a building that has a chiller, would actually consider around 30 to 40% of the building's overall energy consumption 1 year. And adding on to that, you have your fresh air handling units and your air handling units, which again gives you, if you notice, around 22% of the readings. Then you have your common area fan coil units. So all of this, if you look, and chill water pumps along with the chillers, if you notice, it's actually coming to around 50-60% of your overall consumption. So having done this analysis helps us to actually target ourselves and to focus our plan to look at the HVAC system, to optimize it, to identify wastages and what solutions can really be proposed to improve the solution. Then you have lighting, which accounts for usually 10 to 15% of normal buildings load. So here you have car parking lights as well. Here in most of our buildings we have basement or podium parking. So you can expect at least around 15 to 20% of your load in most cases would come for a high-rise building, to around 20% for lighting consumption. Then you have other loads like your plug loads. You have your pool heating. You might be using an electrical heater, so that accounts for around 2%. Then you have for your car parking area, there are these jet fans or axial fans that need to be looked at. So that's that. What data usually is taken into consideration? Again, it depends on the operating characteristic. Like I mentioned earlier, it depends on the assets. So we would spend most of our time studying how the chiller and the HVAC system is operating. So looking at operating characteristics, we would need to measure things like space temperature and humidity across the corridor, a particular zone. We would look at understanding the cooling loads in different zones. So we would take spot measurements of different airflows, temperature readings. All this will be taken. If you look at lighting, we have what are the lighting levels. So we measure the lux levels and things like that. And focusing on the air handling unit and FAHUs, we would look at, especially for fresh air handling units, we would look at what are the CO2 levels. So looking at the air quality side, that measurement will be done. You look at the chill water system, we have chill water flow measurements taken to understand, what is the supplied flow across different zones. Looking at fan pumping power loads, we look at lighting power density, which is again, what is the lighting kilowatt per area of a zone that it's feeding. So all this will be studied in terms of loads. Measurements would again include, I would come to the instrument in the next slide, but we would look at spot measurements as well as interval logging as well. So when you come to data logging, you have things like when are the schedules of operation, whether it's occupied time, unoccupied times, what are the set points. If you look at motor runtime, how long does it run for, when does it start up, when does it stop, what is the load it's feeding. Unoccupied overrides and timers. Do they have any timers in the building to switch off as per schedule, switch on as per schedule? All this is taken. A major point of logging would be to understand cooling performance. So if you're looking at a chiller, we would look at getting measurements like flow, temperature readings, supply and return temperatures. We would look at pressure readings, and finally we look at getting the performance of the chiller either through either through identifying the COP of the chiller or by having the kilowatt per ton rating of the chiller. So if the data is not available, we would make some assumptions, but again, it's all based on different data that we can get, and we would basically calculate the performance and efficiency of the different systems. Now, these are some of the equipments that we use. We are relying heavily on instruments. I mean, good quality instruments like Hioki's. So they have a really good power analyzer that we work with to actually understand what are the different loads in the building, to log it. I mean, it's very easy to use, user-friendly. The interface is pretty straightforward, and it's easy to set up a power analyzer or energy analyzer on MDBs and different loads that we're working on. So that's something that we work with. Then we have different airflow measurements taken for FAHU, fans, air handling units, FCUs. So that would also be required to be taken, to make some performance studies. In terms of pump water flow as well as chiller flows, we use ultrasonic meters to actually understand what are the chill water flows across the buildings and the lines. That is taken into consideration. In terms of understanding temperature readings, we have infrared thermometers as well as thermal imaging cameras. So this works both ways for the building envelope as well as system temperature requirements that we would need to take into consideration. For smaller loads, we have AC clam meters. So if you have SMDB DB loads to measure the current or instantaneous voltage, we would use these clam meters. We would also use different air quality meters, and the lux meters to get the lighting data for different zones as well. Now, just a quick review of the overall audit process. It looks, we have a preliminary audit session where we would plan, we would have the final site audit, and then finally the detailed audit would look at building the energy efficiency measures and giving you a report. So finally, an audit report would look like this. It has to be simple and it should be of direct language, because you don't want to complicate things and lose out the final requirement of the, the output of the audit. So it's usually very simple and direct language. We ensure that the grammar on the report is very clear and straightforward, so that it doesn't confuse the end reader. Most of the things are presented graphically, because we've discovered that presenting things visually gives a better understanding to the end customer and to relay our ideas, whether it be engineering solutions or looking at having some some usage patterns changed, but everything is usually given graphically. Our recommendations are usually very clear, and this is also what is expected of an energy audit report, that the recommendations are very straightforward, crystal clear, with additional documentation or assumptions clearly listed down as well. And what happens in most cases, even if it's a level 1 audit, we try to be as accurate and consistent on the audit report as possible. So usually the contents of an audit report looks at like this. There's an executive summary which should be read by the top management to understand what are the summary of the key findings, what are the recommended energy efficiency measures or energy management opportunities that we have identified, what is the implementation cost, so is it feasible to actually have the solution put forward to, how long will it take for the savings to be returned, savings to be received, and also how long does it take for the money that investment has been done, how long does it take for it to be brought back to the customer or the end user, and any other specific information related to the implementation. So if there could be a very innovative or unique solution that we would recommend to a customer, what happens is any engineering challenge or any specific requirements also is listed down, so that it makes easy sense to get the implementation solution done. Then technical section would look at audit findings, what is the scope that we had agreed on, what are the different assumptions, and finally an appendix of different calculations as well as drawing variations that we've done in the zone. A quick look at ECM design. Again, like I said, we'll focus on building facade, HVAC, electrical systems, lighting, renewable water, irrigation. I'm just giving a snapshot of different solutions and assets that we work on. But there's definitely much more than this, but it's just a snapshot. So we look at if it's the HVACs on the building facade side, we look at the roofs, the walls. So we will have things like air leakage testing done, which again Sharath will be speaking about. On the chiller side, we could have a chiller plant manager to actually optimize the usage of the chiller based on the requirement on site. If you look at the ducted splits, we have smart thermostats, we have anti-fouling agents to remove the fouling buildup that has happened in the condenser coil side of the HVAC equipment. On the electrical side, we can look at optimizing the voltage. If the voltage is not the voltage is higher than what is required at the end user point, we can optimize that. On the lighting side, we have obviously direct replacement from your inefficient lights to LEDs, having sensors in place to be driven by more occupancy and timing of the day. And also finally, once the major measures have been done, we look at implementing or integrating renewable energy like solar, and what is the feasibility of having that to the facility to improve your overall efficiency. On the water side, we look at the taps, shatafs, the wash basin closet and the closets. All of that, this will be taken care of by having water flow reducers or aerators. And on the landscaping side is another area we have good opportunity at having a soil additive to reduce water consumption, having smart intelligent controllers with weather-based systems to reduce the overall deployment of water across the landscaping area, having pressure reducers and nozzles across the landscaping area is also something we look at. This is the final slide from my side. This is just giving you a snapshot of what an ECM summary would look at. This is found in our energy audit report. So the first component would be to just give you a very straightforward idea on what is the measure that we're proposing and which asset that it's focused on. What is the baseline consumption that we had built based on the data that we received? So what is the reference that we're looking to move on to? And then what is the annual savings expected in terms of the unit of the energy consumption as well as in monetary value? So here it's in Dubai, it's in AED. We have also what would be the investment expected, and finally the payback, or how long it would take for that solution to pay itself back. So it's usually listed or ranked based on your payback. So the faster paybacks are listed on the first, and then we go on to the ones that take more time. And also the return on investment is also taken into consideration. So that's it from my side in terms of an energy audit, to give you an overview. But now I'll hand over to Sharath, who will be discussing more on air leakage testing and the importance with respect to with respect to a building's consumption. So I'm handing it over to Sharath. Hello, my name is Sharath. I am basically an air tightness tester at MA level 2, and I also have an ITC level 2 certification for thermal imaging. So basically, yes, today I'm here to talk about air leakage testing. So we carry out air leakage testing here in Dubai. I hope you can see the screen. Hello, am I audible? Yes. Okay. Yeah. So we carry out air leakage testing for here in buildings in Dubai. So it's mostly apartment buildings, or it could be commercial towers. Yeah. So basically, by the end of the presentation, what I would like to convey to the audience would be basically to just give you a basic overview about air leakage and air tightness testing, and finally looking into what exactly are the steps involved in air tightness test and how we prepare a building for the air tightness testing, and of course the significance of reducing air leakages in a mixed use building. So let's define what an air leakage is. So before we come to air leakage, we have to look at what is ventilation. So ventilation is the active process of replacing air in a building to regulate the temperature and moisture. So so ventilation is something that is controlled. It always happens under a controlled condition. For example, in your house, you open a window or a door, or you switch on an HVAC unit. So it's fully controlled. So in case of air leakage, it's the uncontrolled flow of air through the gaps and leaks in the fabric of the building. So so less the air leakage of the building is, the more airtight the building. So of course our aim should be to reduce the air leakage in whichever building we are looking at. So coming to the next slide, we first look into the significance of air tightness. So as my colleague Rijo had pointed out, a major portion of energy consumption of any building is the HVAC, or the ventilation. So here I have based the graph on a study conducted in the USA. But if you look, so here they have shown around 35% of the consumption they have HVAC. But even if you look into Dubai, as Riju had shown, even around 50 to 60% normally of the energy consumption is HVAC. So from that we have an idea of how much energy we are looking at saving if we are able to identify the leaks and we are able to close it and prevent extra overconsumption of HVAC. So the indoor air quality, so that's another aspect that we are looking at, which of course, when we are looking at mechanical ventilations, we have the option to filter the air coming in, which of course is not the case with air leakages. And also the durability of the building. So when there is air leakage, you cannot control the moisture of the building. And of course, you know what problems moisture create inside a building. Coming to the standards. So the standards that we follow is ATMA. It's Air Tightness Testing and Measuring Association. And that's what we follow here for our tests that we conduct. And also ASTM has their own standards. And here basically we have the building codes for each emirate. For example, in Dubai, we have EHS Tarakis, which requires 10 meter cube per hour meter square as the air leakage rate, the maximum air leakage rate. And Abu Dhabi, we have Estidama Pearl building rating system. And of course, the rating system depends on what kind of building are we looking at. Yeah, coming to the next slide. So what exactly do we do here? How do we test this? So we use something called the blower door test. We use a blower door test in order to determine the rate of leakage of air in the building. So the advantage of using blower door test when compared to thermal imaging is using blower door test, you can actually quantify the leakage as opposed to just identifying or where the leakage is, or identifying whether you actually have a leakage in any of the areas. So basically how we do this is we establish a pressure differential across the air barrier, and we measure the flow rate. I will be coming to that in detail in the next slide. So basically we are done with the basic intro. Now we go into the actual test. So this is the instrument that we use in order to carry out the air tightness testing. So in this we have the blower door fan. You can see that here, the yellow color fan. And then you have the frame, the metal frame and the cloth. And then you have a manometer gauge, which we use to measure the pressure. And of course, the tubes that we connect to the manometer. So before going into air tightness testing, we need to define what an air barrier is. So basically, it's pretty straightforward. An air barrier is something that is designed to control the airflow between the conditioned and the unconditioned space. So when the air barrier is continuous, we have a leak-proof system. So the idea is to have a continuous air barrier. So before going into a site, we request for the drawings and we look into the envelope area. So envelope area is basically the area enclosed by the conditioned space that we are going to test for air leakage. So as you can see here, we have cited the different examples. So here in the first one, that's a house, and so it will be the entire outer boundary of the house that we are considering. And in the case below, we have the building. And again, if we are testing the entire building, and yes, definitely we have to consider the entire envelope area of the building. Or the case here where it's just one floor, then we just consider the floor area. Or it could also be a particular unit. Okay. Yeah. So preparing the building for testing. So for preparing the building, we need to firstly close all the external windows and doors. So that is done in order to ensure that the building is at its maximum airtight situation while testing. And also the inlet and exhaust dampers of the HVAC are closed, and all the internal doors are open in order to maintain continuous constant pressure level inside the building, and the HVAC units are closed, and if you have any furnaces or exhaust fans, everything is closed. Coming to the main test setup, we have the blower door fan, which is installed in the doorway. Or if you're testing a house, you install it in the main entrance of the house. So after preparing the house accordingly, we do this, and then we do the preliminary calculation, as in we take the preliminary readings for the indoor and outdoor of the building. So we take the temperature and pressure of the internal and external of the building, and so after this we are ready to begin our test. So first we pressurize the building using the blower door fan, and as per ATMA standards, we have to reach pressures up to 60 pascal. So by pressure, what I mean is the differential pressure, the difference in the pressure between the outside and inside of the building. So once we so at every 10 pascal, we calculate the flow rates for the respective pressure points until we reach 60 pascal. And using this data, we'll be able to calculate the air leakage rate of the building. So in the end, we will, with this data, we'll be able to calculate the air leakage rate, the total leakage area, and the air change per hour. So air change per hour is the volume of air that is replaced every hour, which is also used for certain design aspects of the building. So coming back to the factors that affect air leakage in a building. So I'll just briefly explain this to you as we are running short of time. So there is something called the stack effect. It mainly affects high-rise buildings where the hot air rises above and escapes through the leakage points on top of the building, and the cold air enters from the lower parts. And of course, the wind is another factor where the windward side will be having a positive pressure, and the leeward side will be having a negative pressure. So because of this pressure difference, there can be air leakage. And of course, the quality of the air barrier or the curtain walls. So here in Dubai, we have glass buildings and buildings with glass facades, and the quality of those curtains are very important when we are considering such buildings. And normally air curtains are tested either in laboratory conditions, or we also use a water penetration test. And of course, finally, after installation, we come to air tightness testing. So I'll give you a brief on on how to find the leaks. How do we find the leaks? So basically, we use thermal imaging cameras after. So for example, I'll give you an example. So if we depressurize a building here in Dubai, so we have an external temperature of around 40 degrees right now, and internal temperature will be around 20 to 25. So we can, so when we depressurize, we have outside hot air coming in. So it's easy to detect those thermal anomalies in using a thermal imaging camera. And of course, another method is the smoke test, where we use a smoke generator to see the movement of the smoke, and using the movement of the smoke, we'll be able to detect the leakage points. So I've shown in the diagram, it's pretty straightforward where we normally find the leakages. So I'll just move on to the next slide. So sealing air leaks. So when we come to sealing the leaks that we have identified, so once we identify the leaks, we inform that to the contractor, and the contractor uses different methods like caulking, which is the silicon and could be any other compound. And then there is weather stripping of the doors and windows. And normally what we have found is single pane windows have a lot of leakage, and now mostly it's double pane windows that we found. And the exhaust fans can be covered, and of course the HVAC duct leakages. So that for that we have a separate testing
for covering HVAC duct leakages, where again we use a blow door fan to pressurize the HVAC ducts and smoke for finding out the leakages. So yeah, that's pretty much it. So that due to the lack of time, I had to just give you a brief overview about what an air leakage inspection is, and I hope it's clear. You can put your questions in the question box, and I hand over to my colleague Mithun. He will take you through the electrical inspections part of the energy audit. Thank you.
My name is Midun, and I'm focusing on electrical periodic inspection and testing works. So we can start with the inspection and testing. So what is inspection and testing? Actually, it's a thorough inspection, thorough examination and testing of entire electrical system in a building, starting from main distribution panel to final circuit, including SNDB, DB, control panels, and cables also. Actually, the objective of this inspection and testing is to identify faults, anomalies, and non-compliance standards in electrical installations. The outcome of this will be a report or certificate of, with observations and recommendations. And now let's look into the type of inspections. First one is initial inspection testing. Once the building is completed, we have to perform this initial inspection, and it's carried out for verifying whether the installation is complies with the design and construction aspects of BS 7671, and the outcome will be electrical installation certificate if all the results are satisfactory. The next one is periodic inspection. This is actually a re-inspection of building to verify whether the installation is in satisfactory condition. This is to be done after a certain period of time. It depends upon the type of building also. We'll come to this later. And the outcome will be a EACR, Electrical Installation Condition Report. We will discuss that in detail later. And necessity of periodic inspection testing. The legislation requires that the electrical installations are maintained safe condition for better working environment and human safety also. And some licensing authorities like public bodies, insurance companies are recommending inspection to avoid losses that can occur due to accidents and damages is in electrical faults. And when there is a change of occupancy, the tenant can also ask for a periodic inspection report for ensuring the electrical safety. The next is to assess compliance with the BS 7671. This is a standard. We will discuss later about that one also. And when there is an alternation in electrical installation, it is required to verify whether the alternation is as per standard by performing periodic inspection. And if there is any damage happen to installation, example as a flood, fire breakdown, then also it's required to inspect and verify the condition. And next is process of inspection. There are 4 main steps in inspection. The step 1 is site walkthrough and planning. Actually, this is to familiarize the facility, locations, identify the difficulties, and prepare a plan with the duration and further requirements for executing the inspection. Then step 2 is a site inspection with a checklist. This is the main task actually. There will be a detailed checklist with us, and as per BS 7671. And with this checklist, we will inspect and test the facility. Then step 3, so data verification. Once the inspection is done, it is required to verify the filled checklist. It is okay for preparing the final report. Then step 4, the report preparation. Actually, this is the final step. And here we will analyze the faults that we observed during inspection, and we will prepare a recommendation for the same also. Now let's look into basics of inspection. First one is reference standard. Here we are following BS 7671. It's the main standard reference for electrical installation. This is a British standard applied to design, erection, and verification of electrical installations. This is widely accepted in various countries also. Next is local utility regulation. There will be guidelines prepared by a country or state for electrical installations suitable for their environment. Now let's look into the scope of work, which is applicable for MDB till final circuits. Start with the physical inspection. This is a detailed visual inspection of electrical panels, cables. Here we will use a checklist to identify the faults associated with it. Next is operational test of isolators. This is to verify the disconnection of service by manual operation verification. The remaining tests are applicable for final DB circuits only. The first one is protective conductors continuity test. Here we need to verify earth continuity from equipment and accessories that are connected in circuits. Next is next is one second. And next is ring circuit continuity test. This is to verify the continuity of phase, neutral, earth cables between DB and final circuits. Then polarity test. It is the verification of polarity between phase and neutral circuit side. Then next is earth full loop impedance test. It is to be performed from DB, incomer, and final circuits to verify the continuity of continuity resistance of earth cables. Then insulation resistance test. This test to be done on circuits cable to check the insulation damage. Then next is earth electrode test. This is to verify the earth bit resistance that to be tested from the earth bit also. Then functional testing of RCD. This is a trip test of RCD by injecting fault current. Then facilities and frequency of inspection. Here we can see as per BS 671, there are different frequency are recommending for different facilities. For domestic and hospitals, medical clinics, it will depend upon the facility details. Okay. Then documents required. First one is single line diagram. This is a schematic diagram showing all the electrical panel details starting from MDB till electrical circuits. Then load schedules. Load schedules are documents in the facility in the panels that are showing the breaker details, cable details, and final circuit details. Then power circuit layout and lightning circuit layout. This is the drawing which showing the circuit details and the location of that endpoint. So we can go there and test directly with the reference of the document. The last one is earthing layout. This is required for performing the earth bit testing from the earth bit side. Then we can discuss about the outcome. That's the EICR, Electrical Installation Condition Report, which is a detailed report with observed faults and its recommendation. Then the observed faults will be classified as C1, C2, C3, and FI. FI means further investigation required. Then this is the classification and the description of faults that you can read. Then we can have a look at a poor maintenance panel and good condition panel. In the poor maintenance, you can see the cable line is not proper and obsolete breakers are present. Comparing to good condition panel, you can see the cable line is good and the new generation breakers are used. So this is the main difference. If you're going to the direct panel in poor maintenance condition panel, we can identify more faults comparing to this visual image. Then coming to rectification, actually based on this fault finding and recommendation, it's required to rectify the faults to keep the panel in safe condition. After the rectification work, post inspection to be done to verify the rectification works are as per standard, and so to be documented also. Actually, as per ESFI standard, they had a study on the electrical fatality rates. So you can see here the fatality rate is decreasing due to the increase in electrical safety concerns. So, and the next one is the qualification. Who is an inspector? Actually, the person having good education and training or practical skills knowledge, and he will be able to inspect switchgear and determine age of installation components and recognize the signs of the deterioration also. And he must be having sufficient visual inspection skills and good testing skills also. And the knowledge of that the result data means in concept of ongoing safety of installation also. And the challenges. Let's look into challenges of inspection. For our testing activities, power shutdown is mandatory. In some facilities, it will be very difficult for getting this power shutdown, especially when there is a server present like that, and lack of documents. The power layout and lighting layout is mandatory for some certain tests. In very old buildings, such documents may not be available, but it will be recommended for preparing missing documents. Then support from client. Actually, it is very necessary to identify the location of fans and final circuits. So client support is mandatory. Next one is benefits of electrical inspection. Actually, we can reduce the electrical incidents such as electrical injuries, electrical shock by a periodic inspection. And also it can reduce the risk of fire breakdown by detecting the signs of overheating and pressurized cables, overload circuits. And safe operation of electrical installation can be achieved by detecting obsolete breakers, non-operating disconnectors. Also, we can avoid unexpected shutdown by detecting unsafe circuit connections, wrong breaker selection also. And after the inspection and rectification, the panel will be complying local international standards applicable for safe electrical environment. So actually, this is my presentation. Thank you. And due to the time constraints, we are stopping here. Okay. So I'm handovering to Mr. Rijo for the Q&A section.
All right, thank you, team. So unfortunately, we had to rush in through the ending portions of the slides, but hope we were able to give the information correctly. And now we're open to the next part of the session. So Deepak, if you can let us know.
Yeah, thanks for the presentation. Now we'll move towards the Q&A session. I'll take one by one the questions of the attendees. Okay, so the first question came from Mr. Sanjay. So he's asking how to calculate illumination or lux audit for green energy building areas.
So what we do is there are two things that we look at. So one is the lighting power density. So lighting power density is calculated when you do the what is the kilowatt of the lamps that is across a certain zone. So for example, if you're looking at a corridor, you'll have the downlights. In meaning at least in locally here we have different downlights across the corridor areas. So we would actually look at what is the area of the corridor. We would look at what is the wattage per lamp or fixture in that corridor area, and then we would get the total of the power wattage and divide it by the area and get something called lighting power density. Now the lighting power density is a benchmark value that we can compare with other standards like ISNA. There's a standard called ISNA in the market, so we can compare that and check if it's higher or lower, and based on that we can reduce the overall consumption. So basically replacing it CFL with a LED light would decrease the power in that zone, which would also bring down the LPD. And also in terms of the lux measurements also are taken as part of our audit side. So when you take we have a lux meter. Using the lux meter we find out the readings across the different zones of based on the task. So if it's a corridor, if it's a room, if it's an office building, what is the lux across the site, the table, the functional use is calculated, and then that is how we would work out those readings.
Yeah, thanks for the answer. I'll move towards to the next question, and I would like to request to the all attendees, please put your questions to the Q&A so that we can discuss with the speakers, and you can have the expert comments from them. So I'll move towards the next question. The next question from the Rose Day Villa. So the question is, what is the time frame required to confirm ROI for conducting energy saving activity?
Okay, so that's concerning the ROI. It's a very good question. So, I mean, what we understand is there are two components here. One is the fact that the solution itself has to be technically feasible, and the other component is, also very, very important, which is the ROI. So, specifically with respect to ROI, what we understand is, ROI is the rate at which the investment is recovered. There's also another term called payback period. So payback period is the time taken or the number of months or years taken to recover the money. So what we understand is, in terms of a payback period, a good payback period of a solution would, which usually does go ahead and which is feasible, technically feasible, is within 2 to 3 years. Now that does not mean that any payback above 3 years is not a good payback. Its solution could be good, but maybe there is, again depends on the end goal of the client and the facility. So what we've noticed is a good mix of solutions which have a payback between 2 to 3 years, and maybe 1 or 2 solutions which have payback of more than maybe between 3 to 5 years is actually a good mix of an energy proposal. Because what happens is eventually the mix of different paybacks actually helps to have the overall project payback within 3 to 4 years. So I think, to be honest, if you have something within 3 to 4 years, it is a good project if you're having a complete building retrofit. If you're looking at a single project, like maybe changing your CFL lights to your LED lamps, or if you're having maybe a chiller plant manager across your your chiller system. So things like that could give you maybe again within 2 years time based on the consumption. But if it's an isolated project, that a single project that you would like to proceed, I think within 2 to 3 years is a decent period of time. And if you're looking at an overall project where you want to implement a whole building retrofit, anything between 3 to 5 years is actually reasonable. But obviously, the faster you get your savings back is definitely a plus for everybody. But we're looking at on a realistic basis, anything between 3 to 5 years on a whole building approach makes sense.
Right, thanks for the answer. I'll move towards the next question. So it has been divided into two parts asked by Mr. Vineet Menon. So he's asking, what are the major challenges faced on energy audit? And the next part is, what are the major solutions offered to the client after energy audit?
All right. Okay, that's also a very good question. So the major challenge now, I think, like I had discussed something earlier about, was the personnel involved. So when we go onto a site, usually an energy audit looks like we are coming to point out the problems of the operational team on site. So what we have discovered is that that to have a session with the team is very, very important. I think it would maybe 10% or 20% of the overall effort is actually on this area here. So we actually spend time with the team to understand what are the roles, and then we also tell them, this is not to blame anybody, because see, any facility will have issues that we would encounter, and whether it be operation and maintenance, there are things that people would go unnoticed. That's not to blame anybody, but we want to take it to another a better level of operation and performance of the building. And then we try to bring this philosophy of that we are one team, that if you can give us more data, we are able to actually help you and improve the overall performance. So if the building operates better, it's also easier for the operations team, and it also gives them a shining light. So we actually try to make that and remove any negative mindsets before we even go on to the site audit. And another thing is, obviously, like, top management support is very much required, because if top management is not driving anything, then we, how much of opportunities we can bring forward, it never goes ahead. Now, to answer the second part of the question, I believe it was regarding the solutions that the client usually prefer to implement, right? So looking at that, there are a lot of different solutions. I think I can tie this one to the earlier question as well. The ones that usually give you the faster payback is the ones that usually go ahead. And also the challenge associated with implementing that solution on site also is there. Now, again, there are end users that have a long-term view on this and who are very much pro sustainability driven. So for them, there are cases where we have longer payback projects, but it actually adds a very good long-term value and it really benefits their overall business. So there are cases where we also have solutions like major facade retrofit and even replacement of major HVAC systems. So also go ahead as part of a major project, and that is what that usually the clients go for. So in short, basically the ones that it depends again on the type of client. So some clients, obviously everybody wants to reduce their costs, and one of the areas is definitely energy efficiency measures. So having a faster payback project makes sense. But again, for the long-term clients who are looking at more than just cost savings, and obviously cost savings is one of the components that you will get with it, but apart from cost savings that they see that this project being implemented could actually benefit them on the long run, they would also move in that direction to implement that.
Yeah, thanks for the answer. I'll move towards the next question asked by Thomas John. So the question is, how the smoke test can find the air leakage in the building?
Yeah, I believe that's addressed to me. Yeah, so smoke test, yeah, so in the presentation, I couldn't go into detail on that. I'm glad the question was asked. So basically, there are two ways we conduct the smoke test. So one way of doing it is if you have no idea where the leakage is, then what you could do is there is a smoke generator like the ones you see on the stage during the dance performance. You should be familiar with that. So a smoke generator is used to actually just fill the room with smoke, and then we use our blower door fans to pressurize the room. So when we pressurize the room, and we actually have a person outside the room or the building that we are testing, and we look for smoke coming outside. So by following the leakage path of the smoke, which is a visible entity compared to air, we will be able to understand where the leakages are. So this is mostly in cases where we don't know where the leakage is. So then there are cases where you have a window or a door where you are doubtful, like there could be a leakage there. So you just want to test an area specifically. So there, what you do is you actually have a small smoke machine which is handheld, and again you either pressurize or depressurize the room. So if you are pressurizing, you just move the smoke generator through through the perimeter of this window or door, and you can, by the movement of the smoke, you can have a clear idea about where exactly the leak is and how much it is. So yeah, that's pretty much how we check the air leakages using the smoke test.
Yeah, thanks for the answer. Now I'll move towards the next question asked by Mr. Rohit Shroff. So the question is, what is the standard as BS 7671 for India, or is it applicable for all countries?
So I can answer for that one. Actually, BS 7611 is a international standard, so it's applicable for various countries. It's so applicable for India also. But in India, I mentioned that there's a local regulation so available. So the local body will adapt the standards from BS, and it will be converted to the Indian standard. Depends upon this environment and the connection of electrical supplies and everything depends upon that one. And Indian standard is also available, that's adapted from BS 7671. I think that answer is enough for that.
Okay, thanks for the answer. Now I'll move towards the next question asked by Ahmed Omar. So he's saying thanks for the valuable presentation. And his question is, I have question regarding to the boiler. how to maximize the efficiency of it.
All right. Thank you for that. Glad you enjoyed the boiler, I mean, the energy efficiency presentation. So boiler, I mean, see, again, it depends on efficiency for this comes to how much is the heat output by heat input, right? So there are ways where we can optimize the flow of the oxygen into the the endpoint, as well as how do we get the pressure variation across the boiler itself. So by tweaking these by tweaking these points, we can actually optimize the boiler. And again, it comes down to what is the final end result and what is the load required or expected across the boiler. So looking at this, we can actually optimize it. But we find that in many of the plants that the load is not regulated correctly, which means that the requirement on site will be X, while the boiler water produces will be 2X. So most of the time it's about, like what I mentioned earlier, about wastages, to understand how we can actually look at what the boiler is producing versus what is required on site. So that is one thing. And then looking at the line itself, so the lines from the boiler to the endpoint, we look at how we can optimize that. Then looking at the water side, I mean, we've noticed that there is a lot of fouling across these boiling pipes. So, if you look at, there are solutions which help to optimize or improve the quality of the water to reduce line scale and fouling across the boiler. So if you have, maybe there are these water softeners that you can actually use to put into these coils, which will remove fouling. And, if you remove fouling, you improve heat transfer across the boiler. So that is a simple concept that you can have. Then also looking at, see, again, coming to the wastages, it could be loss of incomplete fuel combustion. It could be a loss of a defective combustion gas. Again, could be the exhaust gas could be again a loss. Maybe your boiler is not well insulated. So these things also that need to be taken care of. Then again, you can do a performance testing on the boiler and see if the performance is actually in par with what is there in the market now. If it's very old, we would recommend also maybe replacing the boilers. But again, that comes only if the performance is very poor compared to what is the standard. Otherwise, you can actually have measures like optimizing this, like no cost measures also put in place to understand what is the requirement versus what is the boiler producing, and then even looking at on an operation maintenance point of looking at having better insulation, making sure the insulation is in line with it's not worn out, there is no heat leaking out of the boiler anywhere, and also having your water tested regularly to see that it's not having the water that is going into the boiler itself is of good quality, or at least fair quality, so that there is no fouling that is expected, because we've seen many times when we do boiler inspections there is a lot of fouling and heat transfer is actually reduced. So you expected the boiler to perform at a certain level, but unfortunately, because of the fouling and the buildup of lime scale and other things, the heat transfer is very poor. So that's something that you can look at. And also, if you want, we can also have later on, if you're interested, we could have a detailed session on boilers later on, where we can discuss and go deep into the depth of to optimize the performance of a boiler.
Right. Thanks for the answer. I'll move towards the next questions. Now we are getting so many questions now, again related to the air leakage. Asked by Ganeshan. The question is, what is the duration for air leakage test?
Yeah, hi. So the duration normally, the idea is to achieve 60 Pascal as per ATMA. Normally, as per the normal standards, it's 50 Pascal, but ATMA recommends 60 Pascal. So basically, we are doing, there are two aspects to this. So as per ATMA, we have to first pressurize the room, and then we have to depressurize the room. So we follow the same steps in both situations. So it depends on how airtight the room is. So normally, if the room is quite airtight, then we can easily attain the pressure levels that we are looking at. So typically, air tightness testing for apartment should take anywhere around 30 minutes, 30 to 40 minutes. But then again, we are looking at situations where you have leakages. Then we have to identify the leakage. So that would obviously take more time. But otherwise, it should be done in around 30 minutes. If it's an apartment building or a ground floor G+1 villa or something on that scale. But of course, when you're looking at bigger multi-story buildings, then of course we have multiple fans involved. Like for example, there was a government building that we had done in Ras Al Khaimah recently. So that was a pretty huge building, and we had to use around 9 to 10 fans to carry out the test. And of course, it took around 2 days, 1 day to set up the fans and 1 day to actually do the testing and find the leakages. So yeah, it definitely depends on the scale of the building that we are looking at.
Okay, now I'll move towards the next question asked by Tanjin. So the question is, what are the possibilities of changing construction materials which make building energy efficient?
All right, so that's an interesting question. So, see, I mean, I think it depends on what we're looking at. So, if the building is already built, then you're talking about a retrofit, right? For a retrofit, I mean, a major retrofit in most cases is not very feasible because of the cost involved and the payback period, and maybe the short to mid-term expectation of the client. But looking at again, it depends on the building. If the building is actually old, and if there is really good potential for savings by having a major retrofit on the facade or the envelope, then yes, it can be posed as a project. But from our experience, what we understand is what clients usually limit in terms of facade is having maybe window films across glazing. So basically, it reflects the solar radiation of the windows, and it actually does not enter the building itself. So it reduces the overall heat gain of the building. Then also having reflective paint done across your roof areas. You could have it across your your walls, where exactly the sun is. You can actually understand the path of the sun, and based on the path of the sun, you can actually paint those walls or facade areas which have the maximum impact of your sun, and then that can actually reduce this saving. Then also again, we also have things like having your solar panels kept in places to actually, which is actually not like your solar panel which is usually found on the roof, or these are the panels that are integrated with your facade itself. So it actually gives you a good visual as well as generates electricity. But again, it depends on the appetite of the end user as well as the feasibility of the solution. But then again, looking at a new design, that is where we're involved with our green building solutions. On the new design, you can actually recommend things that can be done, before it's even built. So that makes sense, and also financial sense, because you are already planning for something, you've already costed for something, and based on different factors like U value and R value of the facade, we can actually understand, okay, this wall is having this much of reflectivity, this much of this is the insulation from that building, and like understand factors like there are things like thermal bridging. So trying to reduce that, then also improving your overall insulation, having maybe a less amount of glazing or glass areas for the heat to easily come in, or even if you're having glazing, try to have maybe glazing with higher U values and things like that. So yeah, I mean, that's how we look at. But on the retrofit side, yes, I mean, it usually stays to to a limited portion where it's mostly having window films on the windows and having reflective paint across your roofs, maximum on the roof. Even the walls, because of the cost involved, is sometimes not taken or gone forward, even though savings are achievable. Yeah.
Yeah, thanks for the answer. Now I'll move towards the next question. So the question asked by Mr. Sadrul. So the question is, how the inspection of LT panel and MBD is done in regard of energy waste encounter?
Energy waste encounter.
Yeah,
Okay.
I'll repeat again. How's the inspection of LT panel and MBD is done in regard of energy waste encounter?
Okay, so I mean, we have again two aspects here. So the number one thing is on the MDB, the low voltage MDB side, we have a power quality audit done. So that looks at power quality and energy logging is done at the same time. So what it does is basically we have a power quality analyzer, and maybe you've seen that we use the Hioki analyzer actually to connect to the MDB area on the incomer side, and we are able to understand what is the trend of consumption across that panel over a period of time. So if it's, let's say, if it's a resident or a mixed use building, then we can understand that over a period of time, the consumption is X, and that on weekdays, this is the consumption, on weekends, this is the consumption. And also looking at, that is on the logging side. Then there's another component where we understand the power quality. So things like what is the power factor experience with different loads. So, usually most of the buildings now that are designed have VFDs or are already designed and constructed with LEDs. So it can actually create harmonics. So what is the harmonics in the system is analyzed on, is it something that we can actually work with, or do we need to actually install other additional, reactors and things like that. So that is another component we look at. And then again, on the inspection side, apart from this power quality audit, we also look at the inspection side, because at the end of the day, if the component within the LV switchgear is not functioning correctly, even if it's not directly directly involved with consumption of energy, it can actually affect the overall purpose of the panel itself. So it might actually have things like overheating. So your current is actually getting more resistance to flow across, which means there's more, that energy which is actually flowing through as current is actually now being translated into heat. So again, you're wasting energy in a way of sorts. Maybe it's not easily quantifiable, but over a long-term period of time, it's not only is it not beneficial to the panel, but you're actually wasting energy in that sort of well. So yeah, it's inspecting a panel, because maybe what we've seen is that the electrical panel does not directly consume energy. It's actually a transfer point for electricity to move in through the building to the asset, right? But the how many times have we seen that the transfer points are weak, and because of that there is actually energy wasted as heat dissipation. So in terms of on the MDB, SMDB and DB levels, or the electrical panel levels, what we're looking at is to reduce heat dissipation, and for the power to flow as per design and as per the requirement of the load. So that's what we look at.
Yeah, thanks for the answer. Now I'll move towards the next question asked by Mr. Hashmi. So the question is, how we decide the rating of building, and this rating differs from one country to another, like LEED or CASBE. I mean, what is the reference to classify it?
Okay, so that's a good question. I think so. How do we classify a building? So I mean, see, here in Dubai, we had done a session where we were trying to build. Some of my colleagues in the market who are actually trying to build a benchmarking platform where you could actually classify where your building stands with respect to the other buildings. So to see, there are international standards for benchmarking in the world, for where we currently rely on them. So one is ASHRAE. ASHRAE, like I mentioned before, they have their own standard for where a building lies with respect to another building. So that is something that we look at, in terms of benchmarking, or to understand where your building lies. But see, that is one way of looking at it. But another portion is having locally built standards. So here in the UAE or in Dubai specifically, there is going to come soon a standard which will actually look at evaluating where the particular building lies with respect to another building. And then if you look, I mean, there are different standards like BREEAM, LEED from USGBC, and ASGB, ASHRAE. Then you have the Association of National Home Builders. So there are different entities across the world which have actually put down a standard. But normally what we look forward to is the ASHRAE standard for benchmarking, where we can identify this is the kilowatt hour per meter square per unit of energy in that for the annual operation of the building. And this is specifically for a hospital, let's say. And if you look and compare, they have a rating or a standard for a hospital, what it should be like. All right, and if it was a school, what would be the energy use index? Or if it was a residential building, what would it be like? Or if it was a commercial building, what would it be like? So there are international standards and local standards, but I think it would basically come down to understanding what your building was basically built for, and what variables are affecting it. And you will see that once that basic understanding is done, then it will always be in line with much below the benchmarking requirement. So benchmarking of international or local standards is just to give you a foundation to build upon, and it does not necessarily have to be that just because you're little above or low that it's actually way from the the consumption, but it gives you a standard for to focus on. And then there are different local building codes, like many of them are now rising up locally, but if you look in the US, you have again USGBC, California Building Standard Code, and all of that. So it depends on what you really look at, but again, this is just a foundation for you to build upon, not something that you need to look to attain, but it's a foundation to go up from.
Yeah, thanks for the very detailed answer. Now I'll jump towards the next question asked by Thomas. So the question are, what are the general recommendations given regarding frequently open doors, sliding doors, manual doors, etc., open to the external environment, especially in the hot Middle East climate, as lots of cool air and hence energy is lost due to this?
Okay, so this is, I think the question is reference to openable areas. There is no particular standard. Ideally, what we will look at is, if the door does not need to be opened, it needs to be closed. But the areas like sliding doors or maybe manually operated doors, we have seen that they're kept open, and if it's a space which is being served by conditioned air, then you're actually just just throwing money out of the door. That's what's happening. So what usually is done is it again depends on top management, drive to actually push, and to create a culture of actually looking for these things where windows or any openable areas like doors need to be shut down. And there are areas where back of house areas within, let's say, a hotel or a mall, where any points of where the door there is a regular chance of it opening. There are we propose to install like window air curtains, and so that can be reduced. So even when the door is open, at least the air curtain is actually blowing and limiting the conditioned air from going out of that particular zone. So that is one way of it. I'm not aware of any standards that tell you to limit the opening of doors, but it's basically comes up to logic that this is a particular zone. That zone is being conditioned by air. So ideally, if you want to save or reduce air from flowing out, you have to close that area. So there are ways we do it, either by it doesn't even have to be sensor-driven automatic doors. It can even have, there are these manual latches which actually close the door once the person leaves. There are simple things that can be done, which actually push that. Then again, it depends. If the client is willing, sometimes we would prefer they would create another small space before the sliding door comes in, so there's like a layer before entering. So that's like a two-layer passageway. And you also have maybe sometimes sliding doors don't make sense in certain areas, but there you can replace it with the the revolving doors, or maybe you can have time sensors. You could there are a lot of different simple and expensive things that can be done. But at the end of the day, I would say it all comes down to awareness. So if you can educate whoever is using the building that, listen, this actually costs money, and not just money, but the comfort and the quality of air that is coming into the building, and the overall aspect of the building is governed by how you use it. So if the person can use the building, and if it comes down to that, definitely I think this is a good opportunity for us, because most of the time energy saving people think it's about using heavy technology, but if we can keep it simple and bring basic awareness, just by doing basic awareness and doing those simple things, you can actually save around 5 to 8% of your overall consumption. The rest, yes, could rely on more technology and retrofits, but just by doing basic awareness, I believe we can do 5 to 8% in savings.
Right, now I will move towards the last question of the session, asked by Mahfouz Ali. So the question is, how much energy is saving by using LED light fittings as compared to CFL fittings, as LED lights are mandatory in India for all type of projects?
Okay, so that's a very good question. So on the LEDs, from my experience, you can get at least 50% savings from your normal CFL or your sodium tube lights or tube lights. So you can basically get at least 50%. Now it can go up, it can go even higher. So it can even go to 70% or 80%. So it depends, because what's happening is your power of your conventional lighting versus your LED's power is definitely minimum will come to 50% if it's a standard bulb in the market. So if you have a good brand like Osram, Philips, and all that, you can get at least 50%. Then further, you can integrate controls to that to improve how the light itself functions. So, for example, I mean, here in UAE, we have a lot of basement car parking areas where we have T8 or T5 tube lights or LED lights, which is running 24 hours a day, even if there's no car in the facility, right? So just by having a sensor-driven or or a time-based system of control on the lights and coupling it with an LED solution, we can actually bring it down to 80 or 90% of the normal baseline consumption, which is a huge thing. And considering that lights come for around 10 to 20% of overall building consumption, if you're able to reduce around 80% of that 20%, that's a good chunk of money that you can save and consumption that you can reduce. So that's something that we would recommend. Also, there are simple things also we recommend is like, if you have in corridor areas, maybe the lux level required in that corridor is X as per the standard, and maybe the current situation is much more than the lux level required, then we also prefer to recommend to the customer that the lights with alternate circuits can be switched off, so that you have one light running, the other light is on, then the next light is running and the other light is on. So it maintains the lux level. You don't have to put any investment into it. It's a simple switching off of a circuit, which helps you to reduce energy without any cost at all. So yeah, so that's what I have to say about that.
Right, thank you. I guess I have picked most of the questions as we have already passed our scheduled time. So thank you for this wonderful session and the presentation and replying for all those questions of the attendees. Now I will ask the Managing Director of Hioki India to come up and give us a small speech so that we can end up the session.
Okay, thank you. My name is Izuka of Hioki India. Thank you so much for joining the webinar, and it was a fantastic session. So the purpose for the webinar is to share the knowledge with you. So we hope you could get knowledge and clue for your current and future job. So, and if you are interested in our product, so for solving the issue that you're facing now, please feel free to contact with us. Thank you again to the seminar. Please stay safe. Thank you.
Yeah, thank you everyone for attending the session. I give thank you for the Middle East team and to the speakers for this wonderful session. So that's it from us. See you next time on our next sessions, which will be keep on coming. We will keep you updated for these kind of sessions. Thank you again, everyone, and please stay safe. Now I will end up the session now.